In this presentation, we'll keep doing some more practice problems on truth tables, determining if a argument is valid or invalid. So here on the screen, you'll see the definitions for valid and invalid again. I'll keep bringing these up for each lecture. The differences here, so for valid is that there's no instances in which all the premises are true and the conclusion is false. Invalid is where there's at least one instance in which all the premises are true and the conclusion is false. So the important thing when remembering truth tables is that we're looking for only instances in which all the premises are true. We don't really care about lines in our truth table in which the premises are not all true. If some of them are true and some of them are false, or if they're all false, we just forget about those rows and we only concentrate on instances in which all the premises are true. And remember that an argument starts as valid and it becomes invalid once you find at least one instance in which all the premises are true and the conclusion is false. So it only takes one to make it invalid. And with that, we'll continue doing some practice problems. This first one is a little bit different from the ones we've done before, mainly because we see that one of our premises is just a single letter. And what we're going to do when we go to evaluate the argument itself and see if all the premises are true, we're just going to use the P that is in the key here. So remember that this represents our key. These values are always given to you. They follow a specific pattern, so then we can make sure that we have all the possible combinations of T's and F's for the three letters that show up in our different statements here. So you see P, Q, and R, P, Q, and R, and then P. So we have to have all the letters that appear in our sentences in our key, and in instances in which either we have a premise or the conclusion is just a single letter, we don't have to make a new column for it because it's already there in our key. Ultimately, if we had P over here, we would just take all of these and copy them over here. We don't need to do that because we've already got them there. So with that, we know that our one premise is there. We have our second premise here, and then we have our conclusion, which we always only have one over here on the far right side. So we just need to do this second premise and the conclusion. So here we've got two operators, and we can tell that the ampersand being inside the parentheses, we've got to do that one first, making our arrow our main operator. So we got to do the main operator second. So let's ignore the P arrow for a second. We'll drop down some dotted lines. So Q and R. The ampersand is true where both sides are true. So we're going to ignore this for right now. So where are both sides true? Well, they're both true here. They're both true here. The rest of them, there's at least one of them that's false. So it's going to be true, true. And then the rest of them are false. With that, now we can bring the P arrow back in. So this is going to be our our right side, or our consequent. The P is going to be our left side, or our antecedent. So if you remember, for an arrow, it is true wherever the left side is false or the right side is true. And so it'll be true here, 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 and here. In all these other situations, we have a true antecedent and a false consequent, so they're all going to be false. So we're going to erase this, and again, we don't need this row. It's only going to confuse us. The only value that we care about here for the for the sentence is the one that encapsulates the whole thing, and that's the one that's associated with the main operator. So now that we've got that one, we just need to do this conclusion, and here we've got two we've also got two operators, and it's the same sort of situation where we've got a P arrow and then a parentheses, but a disjunction here within the parentheses, a wedge. So we got to do the wedge first. So we'll drop down some lines again. We'll ignore the P arrow again, and we can just ignore this. We're just going to use the Q and R to evaluate this one. Where is a wedge true? Well, it's true wherever at least one of the sides are true. That's going to be in rows 1 through 6. The other ones, the bottom 2, 7, and 8, both have falses as both disjuncts, so they will be false. Now, just like before, this will be our consequent, our right side of our arrow. This is going to be our left side. And just as before, it's true wherever the left side is false or the right side is true. And so we've got trues almost all the way except for here in line 7, where we have a true antecedent and a false consequent. And so with that, we can erase this over here. Don't need it anymore. Now all we have to do is evaluate our argument, and to do that, we got to remember that we're looking for instances in which all the premises are true. So let's highlight those. This first row, we have true and true, and that seems to be about it. All these other ones, so this one, it's got a false, and this one, the second premise is false, first premise is false, second premise is false, first premise is false, second premise is false, first premise is false. So this first row is the only one in which both premises are true, and looking at our conclusion, it is also true, so that would make this one valid. And since it's valid, we do not need a counterexample. Remember, the counterexamples are only needed for invalid arguments, and so with that, that is the answer to the first truth table. This one too is a little bit different from ones that we've done before, at least from my memory. Here we've only got one premise, and of course we've only got one conclusion, so we just have to do those two. When we look to test for validity, we're just going to look at our one premise column and see where we have it true, and so it's a little bit easier. We don't have to look at any other column to determine which ones we have to check for validity. So here we've got looks like 3 different operators. And this one might be a little bit more difficult to determine which one is the main operator. So you might obviously see that, the ampersands within this parentheses, anything that's always inside of parentheses is subordinate to some other operator. So the ampersand obviously is the lowest one here because it's within the parentheses. Now the question becomes, what does this tilde govern? How far does it extend? And well, it only extends as far as the parentheses. So this tilde only goes to here, which means our ampersand is our main operator. So we have to make sure we do these in order. We'll do the ampersand with the yellow arrow pointing towards it first. Then we'll have to do the tilde because the tilde is extended over that ampersand. And then final, we'll do the main operator, which is the arrow with the blue ampersand, or with the blue arrow pointing to the ampersand there, connecting the left conjunct and the right conjunct. So let's do this just one at a time. So I'm going to erase, or at least cross out that tilde. I'm going to cross out the ampersand R here, and I'm just going to focus on this ampersand between the P and Q. I drop down a couple. So the P and Q, it's going to be true wherever both of them are true, and that's going to be here in line or in rows 1 and 5. Everywhere else, at least one of them is false. Remember, for an ampersand, it's false anywhere where at least one of the sides are false. So the rest of those are going to be false. Now, with that, we can bring the tilde in, because that's the next next operator that we have to deal with, because it's operating over that ampersand between the P and Q. So for a tilde, all we're going to do is reverse these values that we just had here for the ampersand between P and Q. And so this T will turn into an F, the F's will turn into T's. Like that. And now with that, we can actually erase this middle column so it doesn't really confuse us. We don't need it anymore, because this designates the tilde, which takes into account that ampersand. But we still need to add on the ampersand with the R. So we're going to use this column as our left conjunct. We'll use this column as our right conjunct, and so we're looking for instances in which both of them are true. And we've got that here, here, and here. So all of those are going to be true. Every other row has at least one false, so the rest of them will be false. And now we can erase this, and we can erase this because we don't need it anymore. We only care about the main operator. And so this column here represents the main operator, the one that's connecting the tilde P and Q with the R. And so that represents the value of the whole sentence based on the different combinations in each row. So now we just need to do the conclusion. Let's erase that. And so we have R and tilde Q. Here the main operator is the ampersand. The tilde is just governing the Q, so we'll have to do the tilde Q first. So let's just block that out, drop down some lines. So, ignoring these, we're just going to take these values and we're going to reverse them. T's turn into F's, F's turn into T's, and that's all we have to do for those. Now, we can just add in our tilde, or sorry, our ampersand with the R. So we're going to just ignore those. This is our left side. This is our right side. We're going to look for instances in which they're both true. Well, here they're both true. Here they're both true. And those are the only ones. And so it'll be true and true. And then everywhere else, you have a true and a false here in row 1. You have a true and a false in row 2. False and a false in row 5. False and a false 6. False and a true. False and a true. And so we can just get rid of these now. And so, as I said before, this has only got one premise. So we just want to look at the rows in which the premise is true. We've got 3. And what's our conclusion in each of those? Well, it's false, true, true. And if you remember from last time, so there may be more instances in which you have true premise, well, a true premise, but a false conclusion. You have two that check for validity, or two that check as valid, and one that checks as invalid. All it takes is one instance in which the premise or premises are all true and the conclusion is false to make it invalid. So this is invalid. And what we're going to do, we need a counterexample. So we need a counterexample. And we're just going to read or take these things and transcribe them down here in our counterexample. So P is false, Q is T, R is T. And again, this counterexample is just saying, okay, this is the combination of truth values for each of these individual sentences that say, well, the premise is true, but the conclusion is false. That's all the counterexample is saying. And so when you get to that point, if it's invalid, all you gotta do is just copy those and write them down there as the counterexample. So that's the second one. Look at this third one. This one is a little bit similar to the previous ones that we'd done in the previous lectures. So you've got two different premises. You've got your one conclusion. And so it just is a matter of doing each of these premises and the conclusion, testing for validity. So in this first one, you have two different operators. You have the double arrow and the tilde. And so as you can see, the double arrows within the parentheses, so that's going to be our subordinate operator. We're going to have to do the double arrow and then we can do the tilde because it's outside the parentheses. So focusing first on the double arrow within the parentheses. Remember, double arrow is true wherever they match. So if they match, it's true. Where they don't match, it's false. So here you can see you've got false and a true, true and a false, false and a true, true and a false. So that's what I mean when I say they don't match. And the ones that are highlighted in black, you know, they're both true or they're both false. So they'll be true, false, false, true, and then the pattern just repeats itself. And so with that, now we can bring the tilde back in. The tilde is just going to reverse those values. So T's will turn into F's and F's will turn into T's. Oops. Oh, no, that's right. So false, true, true, false, false, true, true, false. And again, we can get rid of this column because we don't need it anymore. And so that's the value of that premise. Now we just have an arrow for our second premise. So let's not confuse ourselves. We'll just cross out the Q here. So P arrow R is true wherever the left side is false or the right side is true. So that means it's going to be true in all of these instances with the exception of rows 5 and 7. And that's as simple as it gets because it's just a single operator. So now we just have to do the conclusion. And again, just like our first premise, you can see that we've got two operators. The arrows within the parentheses, so that tells us we got to do that one first. So let's ignore the tilde for a moment. And so we've got Q arrow R, as we did last time, and we're looking for instances in which the left side or the antecedent is false, or the consequent or the right side is true. So that's going to be true, 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 true. and false, false, true, true. And with that, just as before, we just flip these trues into falses and these falses into trues because of the tilde. Tildes just flip the value of whatever came before it. And so that's all we need to do for the conclusion. Erasing this. And so, just as we've done before, we're looking for instances in which we have all true premises. We've got those two, and that one is a third. Those look like all of them because here in the first row, the first premise is false. Here in row 4, the first premise is false. Row 5, they're both false. Row 7, second one is false. And row 8, the first one's false. So, the only rows we're concerned with are 2, 3, and 6. And what are the values of the conclusion? Well, we see that we've got 2 of them where we've got a false conclusion, even though we've got true premises, so that's going to be invalid. And remember, for the counter example, we only need 1. We have 2 different options that we can go with. I usually just go with the one that appears first based on the key. So that one would be false, true, true, based on these right here. But we can also write it as true, false, true, based on the values here. So it doesn't matter which ones we choose, it just matters that we have one to be able to show, hey, this is invalid once we have this combination for the individual propositions P, Q, and R. So that's the, I believe, the third one. Moving on to the fourth one here, this is another instance in which we have a single letter as one of our premises, so we don't need to create an extra column for it, but we need to remember that the R column in our key is ultimately going to be factored into determining the validity of the argument later when we go to check for it. So that's one of our premises, but we don't need to have an extra column for it because we already have the values listed underneath of it. Next, we have this one as our other premise, and then this, gotta use a different color. This one is our conclusion. So, looking at this first premise, we have 2 different operators, and by this point you might be able to see that if there's one that's within a parentheses, it's subordinate to anything else outside the parentheses. So since we have this wedge within the parentheses, we got to do that one first. We're going to ignore the P double arrow, and so it's going to be based on just Q or R. And remember that a wedge is true wherever at least one of the sides are true. So here in rows 1 through 6, it's going to be true. And then in rows 7 and 8, it's going to be false. And so now we just have to bring in the double arrow P, so we can erase all of this so we don't get confused. And so the column we just created is our right side, the P will be our left side, and we're going to look for instances in which they match. So they match here, they match here, they match here, and they match here. So everywhere in which they match, we give them a true. And anywhere where they don't match, it is false. And so that is the second premise there. and then we can erase all of this because we don't need it anymore. We're only concerned with the main operator there. Now this one looks a little weird. We have two tildes next to each other, but it's just as you might guess, it just expresses not. It's like saying it's not P. And even though that might seem a little odd to say it that way, but there are ways in which we have words that smuggle in the negation, like invariable, which is not variable. So if I were to say to you something is not invariable, that's really just a not. So there's no limitation to how many tildes you can put onto something. More than likely, in normal colloquial talk, you'll only ever encounter maybe two together, but logic leaves it open that you can have multiple instances. That's neither here nor there. When we're doing the truth table, which we care about doing for now, we're just going to do the same thing as we've done before. So since we have multiple tildes, we can only do one at a time. And as you might guess, the one that's closest to the proposition is subordinate to the one that's further away. So we'll just ignore this furthest left one for right now. If I can mark it out, there we go. So we're just going to focus on one tilde. And what we're going to do, is just flip the values from the key for P. So any T will turn into F, and any F will turn into T. And then, no surprise, we just flip them back over using this other tilde. And so ultimately what we've done is copy the P over here. But in logic, if there's an operator present, you should have a column for it. In your truth table, we don't have one for R independently because it's just a single letter, no operator next to it. This tilde P might be the exact same formulation, the same exact values in this column. Here, those will match identically to these over here. But since there is an operator, at least one operator next to the conclusion, we should have a column for it. Ultimately on quizzes and exams, I'll just be looking for the main operator, so they will just match. But that's just a sort of operational thing there for doing truth tables. So now, just as before, we look for instances in which we have all true premises. We have all true premises here. We have all true premises here. And then the rest of them, we have at least one of them false, at least one of them false, at least one of them false, both of them false, both of them false, one of them false. So the only two that we care about are rows 1 and 3, and as you can see, the conclusion is true in both of those. So this one's going to be valid, and because it's valid, we don't need a counterexample, and so that's it. Moving on to this next one, we have two premises. First one's here, second one here, and then here's our conclusion. So let's just start with this first premise. We've got two different operators. We've got the tilde and the arrow, and here I think probably by now you can see that the tilde has to get done first because it's only tildeing the R. So we're going to ignore the P arrow for right now, and so we can ignore these columns too for the moment. So tilde R, we're just going to take these values and flip them over so that the T's become F's and the F's become T's. Tildes are pretty simple. Like I said, you just take the value and flip them across. Now these are going to be our consequent or right side of our arrow statement, and then the P is going to be our left side or antecedent, so we can ignore these, and we're just going to look for instances in which we either have a false antecedent or a true consequent. And in those situations, the arrow is true, so here, 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 all the way down. Only these two rows 1 and 3 are going to be false. And then we can get rid of this column here. Now here, for this next premise, again, we've got a tilde and we've got an arrow. The tilde is only governing the R, so we know that we got to do the tilde first. Now, if it were written like this, the tilde would be outside the parentheses. That would make it the main operator, and we would have to do the arrow first. But since there are no premises, the tilde is just governing, or sorry, just operating on the R. So let's drop down some lines. We'll ignore the arrow Q. And so what we're going to do is we're going to do the same thing as before. We're just going to take the values of R and we're going to flip them over. So T's will become F's and F's will become T's, just like before. Get rid of those. And now we can do the arrow, but this time these are left side or our antecedent, and the Q is going to be our right side or our consequent. So again, remember, when it comes to these situations with doing a truth table, you might, find yourself reading left to right. You might say, okay, well, what's my left side? What's my right side? Because that's how it appears as you're reading left to right. But you got to remember that this Q column is just the key. Really, these Q values are over here on the right hand side. So you have to picture those Q values over there. Again, you're welcome to copy them down. You can copy them down, and then that way you wouldn't make the mistake. So then you can see that the Q value is here on the right hand side of the arrow. You don't need those. It's just helpful if you feel like you might make a mistake, if you want to be extra cautious. But so, just transcribing those values over there, we can see it a little bit clearer though that, an arrow is true wherever the left or wherever you have a false antecedent or a true consequent. So in all those lines, it's going to be true. And actually, I'm going to go ahead and erase this column just because I need a little bit of space. And I'll recircle them over here. And so it's going to be true, 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 false, false. And then finally, we just have to do the conclusion. Again, we got two different operators, but these are pretty obvious. One of them's within the parentheses, so we got to do the one within the parentheses first. So we'll ignore this. And so we've got just Q or R. For our wedge statement, it's true wherever one of the sides are true. And so here again, it's going to be true all the way down to line 6. And then lines 7 and 8 are going to be false because they're both false. Oops. Now we've got that, we can bring the arrow Q back in, or sorry, the P arrow back in, and ignore these and these. The P will become our left side or our antecedent. These will become our right side or our consequent. And remember that it's true, an arrow is true wherever the left side is false or the right side is true. And so almost all of these are true. that's the conclusion. We can erase some of this. We don't need this column anymore. Oops, sorry, that was the column that we needed. Erase the wrong column. So put these back. True, 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 true. Column we don't need, so possible mistake to make there. Make sure you keep track of which one you needed. So that's the main operator there for the arrow. And so let's compare what we've got. We got to look for instances in which our two premises are true. They're both true here. They're both true here. They're both true here. Both true here. That seems to be about it. So in every instance, in which the premises are true, it looks like we have true values for our conclusion all the way down. So that makes this valid. And since it's valid, we don't need a counterexample. And so that's that one. Next one, we have two premises. We've got our first one here, and then our second one is just a single arrow, which is right there. Or sorry, single letter. And then our conclusion over here. So doing this first premise, we do have a tilde and an arrow, and the tilde is outside the parentheses. So that tells us that we need to do the arrow first. So let's just ignore that tilde for right now. And we're using R and P. Here again, it's important to remember that this is our left side, or our antecedent, and this is our right side, or our consequent. So we got to read them from right to left here. So when I say an arrow is true if the antecedent is false, it's false here, here, and here. And the consequent is, or the consequent is true here, here, here. So again, make sure you're reading the key the right way. You don't just read it left to right. You have to determine the value of an arrow based on what's on the left side and what's on the right side. If you read it from left to right, these truth values are going to be skewed. So it's important to make sure that you read them the way that they're written here in the premise, which is R is on the left side and P is on the right side. So we can erase all that. And we can bring the tilde back in, and remember with a tilde, all you gotta do is flip the values from T's to F's and F's to T's. Like so. And then with that, we can erase this column because we don't need it anymore. The tilde is our main operator. And I accidentally erased it before, but remember that R is our second premise, so let's not forget about that. And then P or Q, we're just going to focus on these two. Remember that a wedge is true wherever at least one of the sides are true. And that is in those rows, so going to be, so again, this row and this row are the only ones in which or both disjuncts or both sides of the wedge are false. So that's the conclusion, or at least those are the values of the conclusion. So now we got to look for instances in which our premises are all true. We've got one here, and we've got one here. The rest of them have at least one of them false. And so looking at our conclusion, we do have one that's false. We do have one that's true, but remember that it only takes one false one to make it invalid. And because it's invalid, we need a counterexample. So counterexample would just be transcribing these values down here. So P is F, Q is F, R is T. And that's it for that one. This next one just has two premises, just like the basic ones we had done before. The difference here is that the conclusion is just a single letter. So here's the first premise. I'm going to use a different color, the one that I got. Make that one green. So there's the second premise, and then our conclusion is just a single letter. So looking at the first premise, we have two different operators. We have the double arrow and the single arrow. The double arrow is outside the parentheses, so we know we got to do the single arrow first. So we'll just ignore that for right now. And so it's going to be Q arrow R. An arrow is true wherever the left side or the antecedent is false, or the right side, the consequent, is true. And it's false wherever the left side's true and the right side's false. So those are the values for the arrow. Erase those, bring the P double arrow back in. And so now the double arrow is true wherever the P, or sorry, wherever both of them match. So wherever P and the Q arrow are matched, so they're both true there. They're both true here. They are both false here. And they are both true here. So in all those instances, it's going to be true. And in all the other instances where they don't match, where one of them's false and the other one is true, it's going to be false. And so now we can erase this column here. And we can move on to our next premise, which is just P or Q. So we can ignore the R for right now. Remember that disjunction is true wherever one of the sides are true. So it's going to be just like the last one. They're going to be true, 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 false, true, 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 false. And then we can erase this. And now we can determine the validity of this argument, looking for instances in which both premises are true. They're both true here. They're both true here. They're both true here. Both true here. And so all the other rows we don't care about. And let's look at the value of the conclusion in each of these. So it's true, true, false, false. So there is at least one instance in which the premises are true and the conclusion is false, so that makes it invalid, which means we need a counterexample. And again, we have multiple instances. We could write this one as our counterexample, and that would just mean we put false, true, false, or we could just as easily write the other one that's right below it. We could write this one, which is true, false, false. Again, you only have to write one counterexample for each invalid argument. On quizzes and exams, a table might have multiple counter examples, but for identifying which one, only one of them will be, or only one of the options that you could choose from will be one of the available counter examples in the actual truth table. The other ones will not correspond to actual counter examples. So that's just to say, when doing quizzes and exams, there's only got to be one option that is actually correct. Even though there might be multiple counterexamples within the truth table. If you are not taking quizzes or exams, counterexamples are not limited. It doesn't matter which one you choose. They're all equally applicable and can prove the point that the argument itself is invalid. Now for this final one, we've got two premises. And conclusion. Pretty straightforward. First one has an arrow within the uh, parentheses, so we know that we got to do that one first. We're going to ignore that. And as I've said before, we got to make sure we read this the right way. This is going to be my left side or my antecedent, and this is going to be my right side, my consequent this time, just by looking at what we've got here. R is on the left side, P is on the right side. So an arrow is true wherever the left side is false or the right side is true. So in all of these instances, it's going to be true. Only here in 2 and 4 will it be false. Once you start doing these multiple times over, it should start clicking and things start going a little bit faster. That's why I'm not spending so much time laboring on each point. But again, it's just best to maybe have the rules written down on a separate sheet of paper or try to memorize them. But the more you work them, the easier it becomes to remember how they operate. So that's why things move a little bit quicker as you do more practice problems. But with that, now that we've got that one done, we can bring back in the Q wedge. So we'll ignore these. And we're going to look for any instance in which one of the sides are true. And it's going to be there. And so it's going to be true, 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 false, true, all the way back down. And then we can lose this because that's not our main operator. And so those are the values for the first premise. Looking at the second premise, it is also got 2 operators. So we'll want to do the arrow within the parentheses first. So we'll ignore this. And once again, we got to remember that this is our left side and this is our right side. This Q is our left side, P is the right side, so we gotta make sure we read it the right way. Q being the antecedent is false here, and P being the consequent is true here. So the value for this arrow is going to be true, false, true, 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 false, true, true. And we can erase all this. And now we can bring back in the R. So what we just listed is our antecedent now, and so our R is going to be our consequent. So we're going to say that this arrow is going to be true wherever the left side is false, or the right side is true. And so we've got trues through here, and so that's the second premise. Now moving on to the conclusion, once we get rid of this extra column that we don't need anymore. So we've got a wedge within the parentheses and the tilde is outside the parentheses, so we're going to do the tilde second. We got to do what's inside the parentheses first. So we're going to just focus on Q or R, and a wedge is true wherever one of the sides are true. It's going to be true all the way through 6. And false in the last 2. And then we just got to take those values and flip them over. So T's will become F's because of the tilde rule. And F's will become T's. And so now we just have to look for, or check for validity. Here we've got true premises. Here we've got true premises. True premises. and true premises. So we can ignore this row, this row, this row, this row. And I should have erased this second column because we don't need it anymore. So I'm just going to erase those. I'll use this time because I don't like what blue looked like. To cross these out. And so here again we see that there are multiple options because all of these are false. So it's going to be invalid. And we could pick from any of those different options as our counter example. I'm just going to pick the first one. I usually start from top and work bottom, but it doesn't really matter which one we pick. And so of the 1, 2, 3, 4 different options that we have, this is one of them. We could have also picked these values, or these values. But that's the last problem for this presentation, and the next one we'll just keep doing some more practice problems.